Okay, in this last problem here, in problem number 10, we have another function is defined by a value a function f of x is defined by a value a times e to the x squared minus 1 power plus bx squared plus 2x squared plus 3x, where a and b are constant. So we have values a and b and they are constant. The function has critical points at x equals to 1 and negative 1. So first of all, when we define critical points of our function, that's when f prime of x will be equal to a value of 0. I know in the past we also define critical points when our function's derivative is undefined. However, clearly here we're not going to have any values that will cause our function to be undefined. We realize e is continuous. He's got a domain that's all real values. X squareds and x squareds are continuous functions. They're polynomials. Then we have 3x at the end. That's going to be a domain that's always continuous. We don't have to worry about any specific circumstances here where we're going to have a derivative that's equal to an undefined value. So specifically our critical points are when f prime of x is equal to 0. And this is when at two particular circumstances, so we know f prime of 1 is equal to 0 and f prime of negative 1 is equal to 0. F prime of 1 is equal to 0 and f prime of negative 1 is also equal to 0 because those are critical points. So we have to determine the values of a and b if they exist that satisfy these criteria. So in order for us to do so, we're going to have to take the derivative of f of x. So we're going to have f prime of x is equal to, a is a constant, so I'm going to keep it out as such. Take the derivative of e to the x squared minus 1. I will have e to the x squared minus 1 power, but times the derivative of the exponent, which is a value of 2x. Derivative of constant negative 1 just goes to 0. Plus bx squared is just 2bx plus 2x squared will give you 4x. Derivative of 3x is just a value of 3. So cleaning this up a little bit, we will have f prime of x is equal to 2x times a. So I'm just going to say this is 2ax e to the x squared minus 1 plus 2bx plus 4x plus 3. So let's go ahead and plug in our first constraint. So I'm going to plug in our first constraint. I'm going to do that in blue. So we're going to have f prime of 1, and this equals to 0. F prime of 1 will be equal to 0. Everywhere we see an x, we're going to plug in a 1. So I'm going to have 2 times a times 1. E to the 1 squared is 1. Minus 1 gives you e to the 0. Plus 2 times b times 1 just gives you 2b. Plus 4 times 1 is 4. Plus 3. 0 then will equal to 2 times a times 1. E to the 0 is a value of 1. 2 times a times 1 gives you a value of 2a. Plus 2b. Plus 4 plus 3 is 7, which implies that negative 7 is equal to 2a plus 2b. So we have our first equation from our first constraint. Now we will go on to our second one. I'll do that in red. So now we're going to find f prime of negative 1. So we're going to plug in f prime of negative 1. So we know f prime of negative 1 also equals to 0. Everywhere we see an x and f prime, we're going to have to plug in a value of negative 1. So this will be 2 times a times negative 1 e to the, I'll write this one out, negative 1 squared minus 1 plus 2 times b times negative 1 plus 4 times negative 1 plus 3. Simplifying this out, we will have 0 equals to 2 times a times negative 1 gives you negative 2a. Negative 1 squared is positive 1 minus 1. This, in fact, goes to 0. E to the 0 is 1. So we'll have 2 times a times negative 1 times positive 1, which gives you negative 2a. That works out very nicely. 2 times b times negative 1 is negative 2b. 4 times negative 1 is negative 4 plus 3. 0 then will equal to negative 2a minus 2b. Negative 4 plus 3 gives you a value of negative 1. Solving this, we will have add 1 to both sides. So we'll have 1 equals to negative 2a. Minus 2b. Let's go back there. 1 will equal to negative 2a minus 2b. And since I want it to be like such, I can solve this very interestingly using simultaneous solution solving. So we can set this up vertically, so we will have negative 7. I'll do it in blue. Let's do that in blue. So we will have, I'll do this in blue, negative 7 is equal to 2a plus 2b. And then from the second equation, we will have 1 equals 2, negative 2a minus 2b. So this is going to be solving this simultaneously via, we can say, an elimination method. 2a minus 2a gives you 0. Negative 2b, 2b minus 2b also gives you 0. And our left side, negative 7 plus 1 gives you a value of negative 6. Does negative 6 equal to 0? Absolutely not. Therefore, since this is a false argument, there are no values of a and b that will satisfy this criteria. So notice here, values of a and b do not exist. So we can write out there are no values of a and b that exist that satisfy the criteria.